You know, for generations, we've all looked up at the night sky and dreamed about setting foot on worlds like Mars and Venus. But taking that sci-fi fantasy and turning it into reality? Well, that requires a massive leap in engineering and logistics. So in today's Explainer, we're unpacking a brilliantly elegant concept that makes interplanetary travel an actually achievable logistical masterpiece. We're talking about the great cosmic harbors of tomorrow. So, let's just get right into it. How do we actually send a massive spaceship to Mars or Venus? I mean, when we watch rocket launches on the news, it kind of looks like a straight shot right into the void. But a journey to another planet? That requires carrying tons of life support, extremely heavy equipment, and an entire crew over hundreds of millions of kilometers. And if we try to make that massive leap directly from the surface of our planet, we basically hit a giant brick wall of physics.
The whole dilemma really boils down to this: launching directly from Earth versus launching from space. From the ground, we are fighting a colossal uphill battle against Earth's gravity. We're pushing through a thick atmosphere, battling friction literally every inch of the way. But launching from space, that offers this elegant, almost beautiful efficiency. It completely rewrites the math of space travel because it removes the absolute heaviest burdens before the long journey even begins.
To break free from Earth's gravitational grip starting from the ground, a spacecraft has to reach a staggering 11.2 kilometers per second. That is Earth's escape velocity. Think about that for a second, traveling over 11 kilometers every single second. Achieving that requires an immense, mind-boggling amount of energy, which of course means packing an astronomical amount of chemical fuel.
And this 11.2 kilometer per second requirement, it creates a massive physical barrier that we call the gravity roadblock. It is a brutal balancing act. Because you need those enormous amounts of fuel, you inherently need massive tanks just to hold it all. This forces traditional spaceships to basically be giant fuel silos with a tiny little capsule slapped on top. Every kilogram of fuel you add forces you to subtract a kilogram of scientific equipment or food or crew space. It's just a vicious cycle.
But early space science pioneers, like Konstantin Tsiolkovsky, realized that trying to do everything all at once was just a losing game. Their brilliant workaround was the stepping stone solution. This whole idea starts with building artificial satellites orbiting the Earth. Now, while we usually think of satellites as being essential for weather monitoring or science research, their ultimate evolutionary role is actually as preparatory stepping stones. They're meant to evolve into permanent outposts and eventually into massive transfer stations.
Imagine a cosmic harbor completely in action. We aren't just talking about a tin can floating in space. We're talking about a bustling orbital laboratory, a construction yard, and a fueling depot all rolled into one. Up there in the zero-gravity vacuum of orbit, ships are assembled piece by piece. Cargo rockets from Earth bring up the parts, the oxygen, and the fuel over multiple, totally manageable trips. The true interplanetary vessel is built right there, safely above Earth's deep gravity well.
Now remember that 11.2 kilometers per second needed to escape from the ground? By departing from a transfer hub instead, that requirement absolutely plummets to just 3.1 to 3.6 kilometers per second. Because the space station is already orbiting the Earth at immense speeds, a ship leaving it only needs a fraction of the additional speed to break away completely. We drastically cut our fuel needs, which suddenly opens up vast amounts of space for the crew and all that vital science gear.
Logistically speaking, this staging process is just brilliantly intuitive. First, standard heavy-lift rockets ferry your parts, supplies, and fuel into Earth orbit. Then, specialized engineering crews assemble the deep spaceship directly at the space station. Once it's fully built, its massive tanks get topped off right there in orbit. Finally, this fully loaded, fully fueled ship departs directly for Mars or Venus. It literally turns a technical nightmare into a smooth, manageable pipeline.
And here is a totally fascinating detail that completely changes how we approach spacecraft design. No aerodynamics are needed. Because these massive interplanetary cruisers are assembled and launched in the vacuum of space, they never ever have to push through the thick air of Earth's atmosphere. They don't need sleek rocket shapes, they don't need heavy nose cones, and they don't need massive heat shields for launch. They can literally look like giant flying scaffolds built in whatever shape is actually most efficient for the crew and the machinery. So with the deep space vessel fully constructed and fueled, final preparations kick off. The astronauts, having arrived at the station in much smaller standard transport rockets, now board their magnificent ship. They step out of the transfer station, which is basically their final tether to home, and enter the craft that will become their entirely self-sustaining world for months or potentially even years. It is the ultimate jumping-off point for humanity.
And the actual departure sequence is remarkably serene. The ship effortlessly detaches and maneuvers away from the station. Because they are already up there in orbit, there is no violent, ground-shaking blastoff required to fight gravity. It is a smooth, highly calculated separation. The ship fires its engines, takes advantage of that super low 3.1 kilometer per second requirement, and breaks out of Earth's orbit to align perfectly with its target planet.
Which brings us to what might be the ultimate fuel-saving secret of deep space travel. Once the ship actually achieves that required speed leaving the cosmic harbor, the main engines don't even stay on for the whole trip. In fact, after just a few minutes of perfectly calculated thrust, the engines are completely shut off. For the remaining 99% of the millions of kilometers between planets, the ship simply coasts through the vacuum of space on pure momentum. Talk about an incredibly resourceful way to cross the solar system.
Of course, that peaceful journey eventually comes to an end, because beyond the harbor lies some incredibly harsh alien shores. Arriving at these destinations presents some extreme and violent challenges. At Mars, the crew has to navigate a thin, oxygen-free atmosphere, while over at Venus, they're facing a dive through incredibly dense, crushing clouds of carbon dioxide. But honestly, the cosmic harbor helps here too. Preparing everything in orbit allows us to heavily outfit these ships with the specific entry modules and heavy radiation shielding required to survive those brutal planetary conditions.
So, we've seen exactly how utilizing space stations as transfer hubs fundamentally rewrites the math and logistics of deep space travel. It bypasses that brutal gravity roadblock and gives us the ultimate launch pad. So, I really want to leave you with this lingering thought today. If space stations are our cosmic harbors, what new shores will humanity discover next? Because once we master the stepping stone, the moons of Jupiter, the rings of Saturn, and the absolute farthest reaches of our cosmic neighborhood are suddenly well within our grasp. Keep looking up.